Next is motion in plane or two-dimensional motion. We may define this motion into two parts. First is called uniformly accelerated, and second is called non-uniformly accelerated. As we have defined this particular term in third chapter, that is motion straight line, where we are restricted only in one dimension, that is only along x-axis or only along y-axis. But in this part, we have to define for a plane, that is for a surface. So we have to use x coordinate as well as y coordinate. So for uniformly accelerated motion, or for which acceleration would have some constant numerical value in both x-axis or y-axis. So we will use equation of motion. So I'm defining you how to solve it. Try to break each term in two different independent axes as x component and y component. So first of all, try to find x component and y component individually, on the basis of which we can define initial velocity, acceleration, displacement. Similarly, for y component, you may define initial velocity, acceleration, and displacement. The only thing which will be common in both these two terms will be time. So time will be common for both. Rest of the whole term will be different along x-axis and along y-axis. Now, using these two terms, you have to find first distance, which is nothing but root of x component square and y component square. Similarly, whenever you have to find speed, just take root of x component square and y component square. Is it clear till this part?
Yes, sir.
Yes, sir.
Sabita, any doubt?
No, sir.
Okay. Similarly, for non-uniformly accelerated motion, in which all different quantity will be some variable, time-dependent, position-dependent function. So we will use calculus method. Let's say R vector will define you position. So it will be along x-axis times I cap, y-axis j cap. If you differentiate it, you will get dx over dt. So it will be along x-axis, d over dt. So it will be along y-axis. So this will be velocity along x-axis. This will be velocity along y-axis. Similarly, if you further differentiate it, you will get acceleration. So it will be d over dt of vx, I cap, d over dt of vy, j cap. So this will give you acceleration and this will give you velocity. Is it clear?
Yes, sir.
Okay, just write it down till this part. I'm giving example related to this whole.
Done, sir.
Done, sir.
Okay, I'm giving you one problem related to this. A body moving at 2i plus 3j accelerates uniformly at 0.3 plus 0.2 meter per second squared. Then find speed and distance at t is equals to 10 seconds. Now just see in this problem, we have initial velocity as 2i plus 3j and acceleration as 0.3i plus 0.2j. So we may break into x component and y component. For x component, initial velocity would be 2 and acceleration would be 0.3. We have to calculate for 10 seconds. Similarly, for y component, initial velocity is 3, acceleration is 0.2, and time is 10 seconds. Is it clear?
Yes, sir.
So now use first equation of motion to find final velocity, second equation of motion to get displacement. So Vx will be equals to Ux plus Ax into t. Similarly, S is equals to Ut plus half AT squared. Just put all the values to get Vx and x. Similarly, Vy equals to Uy plus Ay into t and y equals to Uyt plus half Ayt squared. And then apply these two terms to get distance traveled by the body and speed of the body. Sabita, is it clear?
Yes, sir.
Okay, try to solve. Good, Mariam. Try solve second part. If you put the values in this Vx part, you will get Ax is Ux is 2, Ax is 0.3 into 10, so it will be 5 meter per second. Similarly for Vy, good Samara, Uy is 3, Ay is 0.2 into 10, so it will be again 5 meter per second. U is 2 into 10, 20, plus half A 0.3 into 10 into 10. So it will be 3 into 10, 15, 35 meter. Uy is 3 into 10, 30, 0.2 into 10 into 10. So it will be 40 meter. Now to get distance, it will be root under x square plus y square, 35 square, 40 square root under. You may take 5 square as common, so you are left with 7 square and 8 square root under. So it will be 5 root under. 7 square is 49 and 8 square is 64. So it will be 103, 30 meter. Similarly, speed equals to root under Vx squared, Vy squared. Vx is 5, Vy is 5 root under, so it will be 5 root 2 meter per